Okay, for our next lesson, again, these are review lessons. Make sure, though, if you're having a hard time, you got to be in classroom each day so that we can iron out questions. If you have them, others have them as well. So now we're going to get into solving linear equations. This is probably what you spent the most time on, or at least a considerable amount of time on in Algebra 1. So hopefully it'll be somewhat familiar to you and you'll be able to recall it. So we're solving linear equations. They're just in one variable. So we're answering or trying to answer questions like if I have an equation like 3x equals 9, can I figure out what x is? Well, we're just trying to find out what makes it true. So in this case, if x was a 3, 3 times 3 is 9, that makes it true. There's no other number that x could be in this case to make it true. And that's true of all linear equations like this. There's only one value for x that will make the equation true. Well, in this case, this 3x equals 9 we could solve by what's called inspection. You can just look at it and you can figure out in your brain that 3 times 3 is 9, so you know what x is. But that's not always the case because these equations can get much more complicated. So in order to solve these, we have a nice simple methodology, just a few steps, and you can solve every single linear equations. So let's just take a look at these. Step number 1, equations. Okay, these have equal signs in them. There's two sides of an equation, left side, your left side, and your right side. Okay, and step 1 for solving linear equations is always simplify each side of the equation. So just clean up the left side like it was just an expression. Do whatever you can do to combine like terms, do any distributing. Then you do the same thing to the right-hand side. Collect like terms, do distributing. Okay, so that's step 1. Step 2 now, you're going to work with just addition and subtraction to move variable terms. Okay, remember what terms are, just numbers or variables or a product of a number and variable. So you're just going to use some addition and subtraction to move terms from one side of the equation to the other side. Okay, and when you do this, I should have been a little more explicit here. You want to move anything with the variable in it to one side and all other terms to the other side. Now it doesn't matter if you take these variables and move them all to the left-hand side or move them all to the right. Just try and decide what works best for you and for the problem. In general, I will always try to move my x terms, my variable terms, onto the left-hand side. It just seems to make it easier because at the end you'll end up with just an x equals your answer. So it's kind of nice to get the variables on the left. So you've cleaned up both sides by combining like terms. You've gotten all your variables on one side of the equation, and you've gotten all the other terms on the other side. And then your last step is just going to be to use multiplication and division to get that variable alone. So you'll end up with just x equals whatever your answer is. So in that really small equation above, 3x equals 9, I have my variable on the left-hand side, got all other terms on the right-hand side, and my last step is to use some division, because it's 3 times x. I'm going to divide the left by 3. Whatever I do to the left, I have to do to the right. The 3 divided by 3 right here leaves me a 1x or x, and 9 divided by 3 is 3. So that's the last step, using division in this case to solve the problem. So let's look at a few examples. I've only got 5 examples here. It shouldn't take too long. So we look at the left-hand side. First of all, we can see it's x to the first power. This is a linear equation. That's what x to the first ones are called. We see if we can combine like terms. These are not like terms. So I'm going to use addition and subtraction. All my x's are already, if you think about it, all my x's are already on the left-hand side. So I'm going to remove any other terms, in this case this 5, by subtraction. So I subtract 5 from the left-hand side of the equation, subtract 5 from the right, and I get 2x is all that's left, equals 7 minus 5 is 2. I'm ready for step 3, which is use division or multiplication, in this case division, and I get x equals 1. Okay. Again, very checkable. If I plug that 1 up here, 2 times 1 is 2, and 2 plus 5 is indeed 7, so it does check. Next example, my variable's on the right-hand side. Now this variable doesn't have any other like terms. Nobody else has an x in them. So I'm going to leave that negative 2x where it's at, and I'm going to get rid of the other term that's over here, this 6, by subtraction, the opposite of the addition. Whatever I do to the right-hand side of that equal sign, I have to do to the left. So I do the math. Left-hand side, that's negative 13. Negative plus negative is negative. Right-hand side, I'm left with negative 2x. Right here, these guys just knock each other out. And then for our final step, we divide by negative 2, undo that multiplication. Negative 2 divided by negative 2 right here is just a 1. And on the left-hand side, I get negative over a negative, which just is positive. And you could write 13 over 2. I think it's better to flip this. Okay, so it says x equals, and you could leave it as 13 over 2 if you like decimals. Same thing as 6.5. Either one is fine. Next problem, example 3 here, I believe it is. This is our only x term. It's on the right-hand side already, so I'm just going to leave it there. But there's that 7. I don't want any other terms over there, so I'm going to subtract that from both sides. And if you like that dotted line, feel free. So I've got x over 3. These just knock each other out. 5 minus 7 is negative 2. Now this one's a little bit different to solve. I want this x alone. It's x divided by 3. So the inverse operation of division is multiplication. So I multiply both sides times 3. And what happens here is the 3 on top would cancel the 3 in the denominator, leaving me with just x. And 3 times negative 2 is negative 6. Again, it's better to flip-flop that and put your x on the left-hand side. Here we finally have some math we have to do before we do addition and subtraction. The 8 is alone on the right-hand side. Over here, though, we can do some distributing. So let's distribute that 3. 3 times x and 3 times negative 4. Now I'm going to get rid of terms in order to get this x term alone. I don't want this minus 12 there, so I do the opposite and I add 12. On the left-hand side, that leaves me with just a 3x. These have canceled each other out. 8 plus 12 is 20. And now I'm ready to do a division. X equals 20 over 3. And I'm done. And our last example. Left-hand side, I can't do anything with. These aren't like terms. The right-hand side, I've got some distributing I can do. Negative 2x and negative 2 times 1 is negative 2. Now I'm going to move variables. Okay, I've got an x term on the left, 3x, a negative 2x on the right. So I'm going to take this one on the right and do the opposite. Let's draw a line in here so you can see. The opposite of subtracting 2x from the right is adding 2x. And when I add it to the left, I want to line it up underneath that like term, that other x term. And so after I've done that, I get 3x plus 2x. Still have my 6. Here they've knocked each other out. And I just have that negative 2 on the right. All my variables on the left-hand side are my variable terms. So I'm moving everything away from that side, leaving me with, these cancel, 5x equals negative 8. Now I'm ready for that last step, in this case division. And x is negative 8 over 5. And we're done. You should do well on this homework. Tomorrow we cover this with just some tougher problems, a little more distributing on both sides and variables more frequently on both sides.